All right. So we go into here, and we come down to those shapes, right? So hit the link to Open Metals Depot, right? So that way you can kind of see the shapes and things. But some basic shapes. So this angle iron, some square tubing. And so it's 14 gauge, which means the wall thickness of that is 0.083. We got some 3/8 wall tubing, rectangle tube, some Schedule 40 pipe. This here tells you the size, and then some channel, and then down here is the dimensions for that channel. Okay, so we'll kind of go through drawing all those right now. Okay, any questions? All right. So I'm gonna go here. I'm gonna start. So first thing is start a sketch, right? So start a sketch and pick a direction. So I'm just gonna line them up, all going this way. So I'm gonna sketch on this plane. So what does angle iron look like? Like an L shape, right? So if I come here, but it's still angle, it looks like that. And if you look at this picture, it doesn't always look exactly like that, but it's similar. So like the sides aren't just that big radius. There's sometimes a little radius down in this corner. These can be a little bit different, but there's always a good size radius right there that's in there, okay? So we're just gonna draw that, and we're gonna make it about, I don't know, the same thickness as the material is, okay? Yeah.
Do they get two metals and bend them?
No, it's one piece that's extruded. Okay. So the way they make angle iron, channel, flat bar, all those, is remember when you were kids, you use the Play-Doh thing? You put like a blob of Play-Doh in, you put a little thing on you, and it squeezed it out. That's how they make these shapes. So they're not perfectly machined sides, they're rough, but they just make a lot of that material once they just cut it to length. It's called extrusion, same way they make this piece here, this piece here, this piece here. Anything that's the same profile, just long, is extruded usually. It's the easiest way they can do that. And so the angle iron, 3 main dimensions that you care about. The other ones aren't given because they're not super critical. But we do need to show it a little bit. So we're going to draw it, and we're going to draw these ones here about 1/2 or 3/4 the thickness. Okay. So what size angle iron did I want? 2.5 by 1.5 by 1/4, right? So I'm going to come in here. So what should I sketch? Draw an L shape, right? So I just did line, click there, come over here. You don't have to be super accurate, but taking the time to make sure that it all pops in that little mark there, the little straight line with another line with little dashes on it. That's showing you that line is horizontal. So just if you draw it and you kind of let it snap, like right here, it's snapping, gives you that little box in the corner telling you it's 90 degrees. If you take that, and it kind of snaps to that point. So that's another thing to kind of practice while you're sketching, is letting it snap to that point. But if it's not there exactly, that's fine. You can see here, we've got those 2 little angled lines on both the bottom line and this line I'm drawing. That's showing you those lines are going to be parallel. So I'm going to draw this kind of out of whack on purpose. So how can I make this line up straight? Yeah, so I could go through and do perpendicular and parallel to make those all line up. Yeah. All these lines need to be horizontal and vertical also, right? So it'd be easier just to go in and grab that and hit them all. And then, so it'll snap it to the nearest horizontal or vertical. So first step, make it look kind of right. After this, are there any other of these that I can use? Does angle iron look like that? Now it's supposed to be the same thickness, right? So I can use equals and tell that line and that line to be equal. So now if I grab the corner, I can adjust it and those are going to stay equal. I can make them shorter or longer, that's fine, but they're still going to stay the same thickness. Okay? We want to keep the sketch as simple as possible. So even though the shape has all those fillets on it, we're not going to draw those yet. If you can draw it with it being a sharp corner, draw it with a sharp corner. And then add the fillets later as a feature. So from here, dimension, or hit the little dimension button here, and click that line, come up, click, tell it to be 0.25. And then I can click this line here, move over a little bit, click, and remember that's click and let go. And that's going to be 1.5. And click this one, come down, 2.5. Okay. Now it's all turned black. If I try and grab any corner, it's not going to move. Now I'm ready to move on. Don't move on if you've got edges that are still blue. Okay? That means you haven't told it how big to be. Does it matter if this one's the 2.5 and that's the 1.5 or it's opposite? Does that matter? No. Yeah, so just get those in there. Okay? Doesn't matter which way it is. And then, so I've done that. Now come up, hit finish sketch. Okay? Now it's ready to go. So we go to extrude. So the extrude tells us that we're going to take that shape. We're just going to kind of push it forward or backwards to make it a piece. And so how long is this? It's 12 inches, so a foot. So I just type in 12, and that's going to default to inches if that's what it was. Or I can put in 1 foot, same thing, right? I can say okay. And then zoom out, kind of so I can see it. Okay? What? Yeah, now we're going to have the fillets. If I do so I can grab the fillet right here. Click there. I said I want it to be the same size, so tell it to be 1/4. And then I can tell fillet, pick that line and that line, and tell those two. I said half the thickness, so 0.125. Or I can say 0.25 divided by 2. And so there's that. So if you wanted that to be like 3/4 the thickness, what would you do? 0.25 times 0.75. Okay. So there's that piece. Questions? Super hard, right? Yep. Oh, remember, you've done this for like 2 hours. It'll be easier. It'll get easier. Just remember, small steps, okay? This next one is going to be even harder. So the next one, 2x2 by 14 gauge steel tube. So let's look and see what that looks like. So square tube. Square tube looks like that. Okay. So if you look at the picture, it's got the little drawing is showing this little at the very top middle right here. There's a little thing there. We're not going to draw that. We don't care about the seam. Okay. What? That's the weld seam because they bend that around and then they weld it. We don't care about drawing that. We just want to draw a rectangle with the wall thickness and all the fillets. Okay? So we want to make these outside fillets about 1.5 times. So if they're only the same size as your thickness, you're not going to have any radius in the inside. So let's make those like an inch, like 1.5 times the thickness. Okay. So, but it is 2 by 2. So we're going to start by creating a sketch. Start on that plane, and then we can just draw a rectangle over here. Okay. We need to make sure that this thing can't just float in midair. We need to tell it where to be. So we need to line it up to our origin here. So what we're going to do is we're going to tell it coincident. We're going to pick the bottom line, and then we're going to pick that dot there. See, now turn that bottom line black. So now that bottom line is not going to move up and down. And then we can dimension from the dot over to here. I don't know, tell it 4, 5, whatever. Put it somewhere. I don't care where. Just give some space between your different pieces. Does it make sense? So now, any of these other constraints I can use on this thing? No, they're already. So if I grab this corner here, it's still staying rectangular, right? What do I want this to be? How's a square work? Same side. So what should I do? Yep. Equal there to there. Now when I grab it, it's going to stay a square. Now what? Yeah. Add a dimension. 2. Okay. Finish the sketch. Extrude it. How far? 26. Bring that out. Okay. You all with me here? So what's the next thing I can do to the outside of the shape? Add my fillets. So I'm going to do fillets. I'm going to grab there, 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 and there. So I can pick it, that edge, through the part. It knows that, so if I move, it'll highlight that edge that's back there. Or you can flip your view around and grab it like that. How big did I say I wanted these fillets to be? I want it to be 1.5 times the thickness. So the thickness is 0.083. So what's 1.5 times that? 0.083 times 1.5. Just type it in. Don't do the math. Type in the equation. Let the computer do the math. Right? Computers are good at math. Let them do it. You type in the stuff that you need to know. Okay? And then hit OK. So now it's pretty much there, right? Done? Or do I need to do something else? I need to be hollow, right? So are there any commands that look like a piece of rectangle tubing up there? There's one right there, right? So I click that. This first part where it asks you to select a face or body, that's going to pick something to be open. So that'll be an open side where you can actually see into the object. On a piece of tubing, what's open? The 2 ends, right? So I can pick this side, and then I can spin around and pick that side. Just pick them both. And then what's the thickness? 0.083. And then hit OK. And that's the square tube. That's hard. That was 3 clicks? I'm going to blow your mind right now. I'm not going to put this down. So 1.5, 2.5, put those in, finish, extrude, that out, and watch shell. Shell, that side, that side, that side, and that side, 0.25. So I took out 4 of the 6 sides. I left only the 2 sides that needed to have thickness. Shell. Right here. So I did shell. Same thing I did for the tube. But now instead of just picking the 2 ends, so if I just did the 2 ends, and I told it 0.25, it's going to do that, right? So once you put a number in, you can't just keep picking things. You have to hold control. So if I hold control, pick that, look, I get a U shape. I hold control again, I get an L shape. Each side you pick goes away. Yep. If you already put in a number. If you don't put a number in yet, you can just keep picking faces. So either way you want to do it to make the L-brack or the angle iron is cool. Personally, when I do it, I just draw a rectangle, extrude it, and shell it. I just wanted to show you more than one way to do it. They're both fine. I'm just going to come back here. So the next piece is rectangle tube. I think it's going to, how do you think I'm going to do that? The same exact way I did the square tube, right? So I'm going to come back in. What size was that? That was 4 by 2 by 3/8. So that's 2 by 4. I need to do coincident again to make it line up on the bottom. And I can dimension to there, or I can just dimension from here to here until it be 3 inches away from there. Okay? I don't care what you do, just make them lined up, make it look neat. Okay? And stop, extrude, how far? 18. I don't know why I told you to do all these different lengths. It doesn't matter. But now what? Shell? Really? I need to do my fillets. So fillets, there, 0.3, or so I can just do 3/8 times 1.5. And now I can do my shell, there, and there, 0.375. Okay. Questions? What? Right here. I said it was 4 by 2 by 3/8 wall. And then I had said that the fillets on the outside should be about 1.5 times. They're not always perfect. What? What? You type in the number. Because that way, if you just move your mouse, you're not gonna be exact, maybe. Or you'd have to like know what size that is. But I don't have to know that if I'm gonna just type 3/8 times 1.5. I don't need to know what 1/2 is 3/8 is. I don't want to do that math. Let the computer do that. Remember what I tell you day one about me? I'm lazy. Just doing math, lazy? No, it's not being lazy. Let the computer do the math. It's very good at doing math. I am not very good at doing adding and multiplying and dividing stuff in my head. The computer can do it faster and better than I can. Let it do it. Okay. Yeah.
So if your kids have any questions on that, like, oh,
I help them set it up, and then to solve the stuff, I ask Alexa, or I get out my phone, or I use the little math app. Like you take a picture of an equation and it shows you how to solve it. I use that because then I can show my son, like, okay, this is the next step you need to do in this. So, like, setting up the problem is the important part. I know how to do that, but all the different solving stuff, yeah. And my son's in 7th grade and he's already to algebra or pre-algebra or whatever. So, and I only went to trig and stats. I did pre-calc, but did not pass it. So, he's going to pass me pretty soon. Luckily, my nephew lives with us and he's like 4th semester calculus already. And my best friend, one of my really good friends, is the chair of the physics department at Fresno State, so he knows all the math. So I'll just have, if it's above me, I have other people that can help them. Or this thing called Khan Academy. It can solve stuff. So, all right, so there's that. All right, let the computer do the thing it's good at. What's next? Come over here. So this is 5-inch schedule 40 pipe. So with round stuff, you have tubing and you have pipe. Pipe is thicker than tubing. Pipe is set up by kind of the inside. Pipe is set up by the inside thickness and the inside diameter and a thickness. Tubing is set up by the outside diameter and a thickness. Okay. So this pipe is 5-inch schedule 40. So schedule is kind of a number based on how thick it is. So like if you buy PVC pipe at the store, they have schedule 40, schedule 80. Schedule 80 is thinner than schedule 40 is. Yeah. Or is it the other way? Pretty sure the schedule 80 is thinner than schedule 40. Yeah. So that's what this is. So if you look at this, 5-inch schedule 40. The wall thickness is 258, and the outer diameter is that. So that I actually gave you what the dimension is. Okay. So if we go back here, and you can see they have still round tube, DOM, still round tube welded. So DOM means there's no seam. It means it's extruded out of the circle, no seam. Welded means it's flat. They roll it and then they weld it. Pipe down here somewhere. Steel pipe means that you're measuring from the inside diameter, not the outside. So if we look at this tube, it tells us the OD and the wall thickness and what it is. So you can see these are pretty thin wall stuff. Yeah, OD means outer diameter. ID is the inside diameter. When we get to pipe, we have the inside and then that. So if we pull up a calculator, there we go. And I do, the thickness is 0.258 times 2, 516. So it's not quite. So it's not an actual 5 inches. It's close to 5 inches. So oops, 0.258 times 2 minus 0.563. So it's almost 50 thousandths away from 2 inches, but it's roughly 2 inches or 5 inches, whatever it is. But go with these numbers. So here it actually gives me the outer diameter and the wall thickness. Those are the numbers we're going to go with. Okay. So I'm going to need a cylinder that's 0.5, that number. So I'm just going to select it, right click, copy. Okay. So I'm going to go to Fusion, create a sketch right there, draw a circle, click, out, just coincident, or oops, I can't do coincident. I can do horizontal though. I can click that point and that point. So now that can go, it can't go down, but can slide side to side. And that can dimension from there to there. Whatever it is. And then now I can put that and put in, just paste my number. Finish, extrude, 3 feet. And now, again, shell, pick both ends, and my thickness is 258. 0.258. So that's that piece of pipe. If I click on this, it'll tell me what the radius of that is. Or if I hit inspect and I pick on it, it'll tell me what the diameter is. So that's what I calculated. So it's a little bit over 5 inches, but it's close. And that's just how they call out pipe. Don't ask me why, I don't know. I just said don't ask me because I don't know. Right? So there's that. Questions on those? Those first four? Yeah. So when we did the shell, because we're drawing the outside, we're telling it to shell to the inside. Sometimes you might draw the inside of something and shell it outside. So like if you were making something to go over something, so like I wanted to make a sleeve to go over this, I could draw this size and then shell outwards. So that would be a sleeve to go over this thing. Okay. So now what's the next piece? Now I've got this piece of channel. So C shapes. So this same thing kind of goes for I-beams, W-beams, all those things. Okay. Does anyone know what these numbers stand for? Yeah, the C is for channel, the C channel. The 3, so I told you to do 3 by 5. So let me grab this, blow that up a little bit. That does not, let me make that picture bigger. That's not helping at all. There you go. So that's that thing. And I'm using this. So I'm going to grab this so we know what things are. There you go. All right. So this is what C channel looks like. It's kind of 3 sides, but the insides there and there aren't vertical. They're at a little bit of an angle. Okay. Oh man. So let's look at the numbers. So C3, are any of these numbers a 3? Right, so we want 3 by 5, right? Yeah. So the first number, the 3, any of these numbers a 3? Yeah. The depth. So that's this measurement, right? The entire size that way. So that's what that first number is. So C whatever, that first number is that measurement. So C5 means that it's 5 inches across. C3 means it's 3 inches across. Okay? The second number, the 5, is that in there anywhere? Nope. That's how much it weighs per foot. So 1 foot of this material weighs 5 pounds. 1 foot of C3-6 weighs 6 pounds. Okay? That's, so I-beams, C channels, that stuff, It's the measurement, the main measurement, and then how much it weighs per pound. Okay. So what's the overall height of this thing? So what's this measurement? No, 3 inches is this measurement, is D. 1.5. So that's saying it's BF right here. BF is 1.5. Okay, does that make sense? So I don't know, learn how to understand beams and read a complicated drawing. That's, hey, guess what this class is about? Reading drawings, right? Making drawings. This right here is called a tabular drawing. We'll talk about these more later, but basically you have a picture with letters on it, and then a table showing us based on the different parts what those dimensions are. Okay? It's called a tabular drawing. So how am I going to start drawing this? What's the first step? Make a sketch, right? So I'm going to create a sketch on there. And what am I going to draw? What's the basic shape of this thing? A rectangle, right? I'm going to do it standing up just like this one is, okay? So same thing, coincident, my origin to there, dimension there to there. So that locks that in. Now what dimensions do I have for this? What's this measurement? Yeah, just my 1.5. What's this measurement? 3. So I finish, extrude. I said 2 inches. Or 2 feet, right? All right. So now I've got that basic shape. Now I need to cut out the inside. So how can I cut out the inside of this thing? Can I do shell? Shell's going to make the sides flat, right? Yes, I could shell, and then I could make them angle later. That's too much work for me. Remember, I'm lazy. What view am I looking at right here? No, of this part. Am I looking at this side? Am I looking at this side? I'm looking at this side, right? So maybe I just make a sketch there. So if I make a sketch there, and basically it's going to be a line, and a line, right? So why not draw that? So I'm just going to come in, angle down a little bit, come straight, and then angle up a little bit. Right? Isn't that basically what I need to cut out? It's not the right size yet. It's not related to the same yet, but that's the basic thing, right? So what do I need to do to this to make it look right without looking at sizes? Just how do I make it be right? Is it supposed to be, no, not extrude, because that's the next step. So I need to make this, is this supposed to be centered, or can it be like anywhere in there? Should be centered, right? Because we want both sides to be the same. So the way I can center this is if I draw a line, and I kind of go down until I get to the middle point here. See that? The little triangle. And then I come over here and go down until I get to the triangle. And then I tell it to be horizontal. Oops. That's not what I want. It's okay. I can just click this, drag it over here. But now, if I move this point, look, those two corners are centered. I'm still not centered out here though, right? So if I make those two lines equal, now those stay centered and those stay centered. Okay? So that's all going to stay centered on there. Yep.
Is there no way to make that centered?
I could draw a line here. So instead of doing that, I could draw another line. So let me make this very not centered. Come on. Right. I could draw a line from here to here and then use midpoint on the little line and the edge. And now that's centered there, that's centered there. So I was keeping these ones equal to each other. Either way, just I usually don't like drawing a line on top of a line. But I could have done that from if I just drawn, you know, a line, gone up, over, done that, and then just kind of made this go here and done that, and now I can tell it midpoint this one to that one, and then equals there to there. Now it's behaving. So those work, both those work. So what was that? Yeah, it's less work, so that's the way I do it. So now we look at our other dimensions, see what we have. So where did that go? So up here, that dimension is TF, right? Yep, right there. So that's going to be TF here, 273. So we can dimension from here to here, 0.273. And then down here, K. It is. Because we made it symmetric, right? Or we made it lined up at the midpoint. We don't want to have to put in dimensions more than once. That's why we made it lined up.
So if you put like all the lines equal, those lines, whatever you do, the first one is the second.
Yep. So then we can either put in K or T. So T is 1/5/8, so let's just put that in. And then yeah. So the web is TW. I think that's, where did these go? Oh. What is that? The thing. These numbers are. See what happens when you pull up a chart and you think everything's on there? I think it's missing some stuff. I want that dimension, which is X bar. Oh, here it is. So this dimension. So right here, X with the line over it is right here on the chart. And so with a 5, X with the line over is 439. So that's what I want there. No. See, that's another reason I don't like that one. When I did that line there, the midpoint, it wouldn't let me put in that other number. But having this one over here, it lets me do it. So another reason I like doing that line. Sometimes when you try and put stuff in, the numbers just don't go. Figure out another way to make it work. So that's the size. Now I can finish. Extrude. I can just pick this. And then for distance, I say all the way through. And nothing happens because it's trying to go away from the part. So just hit the flip button and it'll go through it all the way like that. And just to kind of make sure, I'm going to hold there. Oh, wait a minute. That K looks like it's going to the fillet, not to where it'd be sharp, huh? Yeah, because this isn't showing us. The T is not from the sharp corner to the sharp corner, it's from the flat part. So it looks like I'm going to undo. Undo again. So I'm going to take that out. Those other numbers are right though, right? So if the T is really the flat part, this is where you need to draw the fillet on the sketch. Okay? And drawing both sides of this is going to be complicated. So I'm going to simplify. Remember, I told you sometimes you have to kind of figure things out. Sometimes it's easier to go back and just change how you're doing something than trying to fix it. I'm just going to draw half of this. And then, so I need to add a fillet there. So I'm going to create, or right here, sketch fillet, there, and it looks like it's about the same. So I'm going to start with like 0.3. And then I'm just going to dimension from here to that end of the flat. And I'm going to do the 1.625. That's 1 5/8 divided by 2. Okay. So now I've drawn half the shape. Instead of trying to do it on both sides, I'm just going to do it on half of it. Okay. But now that looks more like what that does, right? That first angle looked like it was too much. And if I decide that, oh, I think this should be a little bit straighter, maybe 0.4. Oh, no, that's straight up and down. So maybe 0.3 is, that looks a little more like it. So 2.3 for that radius. Okay. Now I can hit finish and I can extrude that again all the way through, flip direction. Okay. So I've got that cut going there. Now I need to do that for this other side, right? Do you think I need to draw that again? Mirror it. So I want to create a shape. Modify is I'm going to take what's already there and I'm going to change it a little bit. Create is I'm going to make a big change to it. Okay. So I'm going to go to create. There's an option down here called mirror. So it basically flips it over. So I can pick mirror. And I can tell it I'm going to mirror a feature. So I can either mirror individual faces, features, so like that extrude, body, so solid parts, or components, which we haven't talked about. So I want to mirror a feature. And we're just going to pick it right here. Pick that feature off the timeline. Now the mirror plane means what it's going to flip over. So I want it to flip over that line, right? Halfway through. So I just click there, say okay, and there's my piece. So I can zoom out and see all my pieces. Yep. No, these are square corners here. Oh, you mean up here?
Yes.
Yeah, it needs to have a little bit of a fillet. So let's do that. So those were 0.2. So let's try an 1/8. Maybe 5. Yeah, that looks better, right? There you go. So that's that. Okay. Questions? So in about 10 minutes or so, I'll upload this video because it's going to take a little time for it to process, save, and then for me to upload to YouTube. Okay? So in about 10, 15 minutes, I'll upload it, which will be fine because I'll be at the end of lunch or at the end of break.
Thanks so much.
I want to go back and finish my lunch. Any questions? So more stuff to learn, right? Take it slow, okay? And so you saw I've been doing this for a long time, and I still had to go back and refigure some stuff out. It happens. Okay? What? I know it looks hard. It's not really that hard once you get into it. Okay? Remember, once you start using it a little bit, it'll become easier. I guarantee that. Okay? Don't get frustrated right now. Yeah, the goal is do these. That's it. Today's is work on these. If you finish these, draw something else. Okay? What? Hopefully you finish today. You've got 3 hours left. I guess, but if you finish it and you're totally comfortable, yeah, leave. If you finish it and you're not sure about stuff, practice some more. And you can draw these more than once. Even doing the same thing over and over makes you more comfortable with it. Sometimes doing the same thing more than once is good because do it once slow, then you can do it again faster. All right.